12.1, Sum and Difference Identities. Now, working with this type of section, we are going to be taking a look at a specific angle in radians, and we will be either creating some type of addition equation or a subtraction equation using the unit circle values to create that answer. So, as a quick example, we're going to go ahead and take a look at 7 pi over 12. Using 7 pi over 12, we are going to create some type of addition or subtraction problem that would give us 7 pi over 12. Now, there are different options you can take. First would be 5 pi over 12 plus 2 pi over 12. Now, this will not work. At first, you might be thinking, okay, well, 5 pi plus 2 pi will give you 7 pi. Why does this not work? Well, even though we are working with 2 pi over 12, which is the same as pi over 6, notice that is part of our unit circle. When we're looking at 5 pi over 12, that is not part of our unit circle. So we have to choose a different set of numerical values that will still give us 7 pi over 12, but is found on a unit circle. Best example here would be 4 pi over 12 plus 3 pi over 12. Once simplified, this will give you pi over 3 plus pi over 4. In this case, those values would work. Let's go ahead and take a look at slide 2. In slide 2, we are given a slide full of various examples of sum and difference identities. Now, there are multiple ways of getting some of these answers. Please keep in mind that although many people will end up creating different equations, the final answer will still be the same. So the identities that follow are used to find the exact value of an angle that can be rewritten as a sum or difference of two special angles. So if we take a look at some of these examples, if we take a look at our first example here, 15 is equal to our 45-degree angle minus our 30-degree angle. We could also say our 60-degree angle minus our 45-degree angle. So there is more than one way to calculate some of these angles. Highly suggest just be sure that you are working with your unit circle, your values, in order for you to be able to create a proper equation. In slide 3, we begin to take a look at different trig equations, specifically with sine. Now, whether it is a sum or a difference, in either case, what we are going to see is that these two values, the u and the v, are both your angles. Now, whether it is an addition problem or subtraction problem, something to keep in mind is that the signs will remain the same. So if you are watching the sine of 30 plus sine of 40, our equation over here would give you an addition problem as well. So our sign does not switch. Let's go ahead and work a sample problem using this exact same formula. If we were to go ahead and work the same problem that we did before, sine of 7 pi over 12. This would be the same as our sine of 4 pi over 12 plus sine of 3 pi over 12. This would be the same as the sine of pi over 3 plus pi over 4. Keep in mind, this would be our u, this would be our v. Okay? Now, we always have to make sure this portion is equal to a special angle on our unit circle. We're going to go ahead, we're going to start writing out our entire equation. So the sine of u, so the sine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 4 times the cosine of pi over 3. We're going to go ahead and solve and get specific values for each one. The sine of pi over 3 would give us the square root of 3 over 2. Cosine of pi over 4 would be square root of 2 over 2 plus square root of 2 over 2 times 1/2. You're going to multiply the left side together, which would give you the square root of 6 over 4 plus the square root of 2 over 4. In this problem, your final answer will be square root of 6 plus the square root of 2 over 4. Let's go ahead and take a look at slide 4. So this problem is done the exact same way. Main thing to keep in mind here is, first, keep in mind our original problem is the sine of a negative pi over 12. Now we have to find two things that will give us a negative pi over 12. In this case, 3 pi over 12 minus 4 pi over 12. Now, keep in mind, we will be using our sine formula, and we know that due to sine being on the outside. These two values work because as we go ahead and plug in sine of pi over 4 minus pi over 3, we go ahead, write out our equation. Sine of pi over 4 cosine of pi over 3 minus sine of pi over 3 times the cosine of pi over 4. Find the specific values for each one. Square root of 2 over 2, 1/2, minus square root of 3 over 2 times the square root of 2 over 2. Square root of 2 over 4 minus the square root of 6 over 4. Final answer here would be square root of 2 minus the square root of 6 all over 4. So another method that could have been used is the even-odd identities, which goes ahead and pulls out that negative to the very front and working the problem that way. Either method does work for this problem. I highly suggest you find something that will make it a little bit easier for you to work with. And what I would suggest is the method that we did over there on the right-hand side of our page. Let's go ahead and take a look at slide 5. In slide 5, we are now taking a look at cosine and the sum or difference formula. Now, there are certain things to keep in mind when working with cosine. First thing would be every single time that we're working with cosine, notice our signs do switch every single time. Another difference would be the trig values and the trig signs that are on the left side are both cosine. The ones on the right-hand side are both sine. So if we were to go ahead and work a problem similar to this, let's say we had the cosine of 11 pi over 12. First, we would have to figure out our equation. In this case, for 11 pi, you could have 5 pi and 6 pi over 12. But notice 5 pi over 12 would not give us a value that we could easily solve. So here we are going to want to use 3 pi over 12 and 8 pi over 12. Using those values, so cosine 3 pi over 12 and 8 pi over 12. This would go ahead and simplify to cosine of pi over 4 plus 2 pi over 3. Although we become very familiar with our 30, 60, and our 45-degree families, we still have to remember that there are more simple angles than just pi over 3, pi over 4, and pi over 6. In this case, keep in mind this would be our u, and this would be our v. So we start off with the cosine of pi over 4 times the cosine of 2 pi over 3. We're going to do the opposite value than what we did here. Notice within our parentheses we had an addition sign, which means we will subtract, and we're going to have sine of pi over 4 and sine of 2 pi over 3. We're going to go ahead and provide the specific values for each one of these. Cosine of pi over 4 is the square root of 2 over 2 times negative 1/2 minus square root of 2 over 2, and the sine of 2 pi over 3 would give us the square root of 3 over 2. Here we end up with a negative square root of 2 over 4 minus the square root of 6 over 4. Final answer would be negative square root of 2 minus the square root of 6 all over 4. Let's take a look at slide 6. Here we are finding the exact values. Notice in this case, this is the exact same problem that we were working before. Now, what we were stating before was it does not matter what numbers you choose as long as the end value is the same. Keep in mind, when we're looking for cosine of 15 degrees, in this example, we're using the numbers of 45 and 30, but you can go ahead and use 60 and 45. So let's say we had the cosine of 60 minus 45, which would be the cosine of 60 times the cosine of 45 plus sine of 60 plus sine of 45. We go ahead and find the values for each one of these. That would be 1/2 times the square root of 2 over 2 plus square root of 3 over 2 times the square root of 2 over 2. We go ahead and multiply everything out. Square root of 2 over 2 plus the square root of 6 over 4. Make a correction right here. This is actually going to be a 4, not a 2. Final answer would be square root of 2 plus the square root of 6 over 4. Keep in mind, these answers are the same. Let's go ahead and take a look at slide 7. In slide 7, we're actually working our way backwards. In order for us to work our way backwards, we first have to identify the equation that we're working with and understand that if we have cosine in the very front, that means we are working with an equation that is a cosine. Also have to take a look at our sine and think of the opposite, which is going to be a positive. In this case, we would start off by compressing everything together. So the cosine of 40 plus 80, we bring that together into the cosine of 120, and we can actually solve what the cosine of 120 is, which is a negative 1/2 as the final answer. So, number one thing is to pay attention to the order by which your trig functions are lined up, and that will help you determine what is the trig function that's going to be on the outside, but it also is going to tell us whether we are going to be flipping the signs or keeping them the same. Let's go ahead and take a look at slide 8. In slide 8, we are taking a look at the problem being given to us. Now it says, it is known that the sine of A is equal to 3/5, and it provides us with a range. In this case, what ends up happening? We're going to need to graph out this equation. Keep in mind, it is giving us a range between pi over 2 and pi. Pi over 2 would be a 90-degree angle. Pi would be 180. This means that we are going to be in the second quadrant. Our alpha says that we are going to be using the sine of A as 3/5. Now keep in mind, we are working with SOHCAHTOA, which means for sine, opposite over hypotenuse. Opposite would be 3. Hypotenuse would be 5. Keep in mind the hypotenuse will always be positive. You're going to go ahead, you're going to solve for that missing sign. In this case, 3 squared plus b squared is equal to 5 squared. 9 plus b squared is equal to 25. B squared is equal to 16. B is equal to 4. Now, considering the placement of our side, remember, because we're in quadrant 2, our x values going towards the left will decrease. So that means that this is actually going to be a negative 4, not a positive 4. Once we find our third side, we are going to find the cosine of A, which is our first problem. In this case, our answer would be negative 4 over 5. Let's take a look at our second problem. Here we have the sine of B is equal to negative 1 over the square root of 5. And it says it is also equal to negative square root of 5 over 5. Keep in mind, the reason why it's telling us like this is because it has been rationalized. We're going to go ahead and do the same thing over again. We're going to go ahead and graph our equation. We're going to take a look at our domain. Here, it is telling us that we have our angle of B in between 3 pi over 2 and 2 pi. 2 pi is at the 0 or 360 mark, and we have 3 pi over 2 at 270. This means that our angle will go ahead and be in the fourth quadrant. If we're looking at sine, opposite over hypotenuse. Keep in mind, our hypotenuse is always positive, which means if we are looking at a negative problem, our -1 would have to be everything except the other term besides the hypotenuse. We're going to go ahead and solve for that. So -1 squared plus b squared is equal to the square root of 5 squared. So 1 plus b squared is equal to 5. B squared is equal to 4. B is equal to 2. Now keep in mind, in this case, our third side is going to be a positive 2 because we are extending towards the right-hand side. To find the cosine of b, notice we are doing adjacent over hypotenuse, which means this answer would be 2 over the square root of 5. Our last problem is going to be C. Now notice we've been given the cosine of A and we've been given the cosine of B. Our equation for this problem is going to be the cosine of A times the cosine of B minus sine of A minus, sorry, not minus, times the sine of B. We're going to go ahead and start finding these answers. Now, cosine A and cosine B have already been found through our answers, so this is going to be -4 over 5 times 2 over the square root of 5 minus, now the sine of A, we go back to our equation at the top. The sine of A was originally given as 3 over 5. And the sine of B was, notice, also given at the very beginning, which was a -1 over the square root of 5. We're going to multiply everything together. -8 over 5 square root of 5 minus 3 times a -1. It's going to leave us with a -3. Now keep in mind, since we have that 3 in between, that will actually cause it to be a positive 3 over 5 square root of 5. -8 plus 3 is a -5 over 5 square root of 5. And this can simplify to a -1 over the square root of 5 as a final answer. We're going to go ahead and look at slide 9. Let's go ahead and work this problem out. If you want to work this problem ahead of time, pause the video now, work on the problem, and check your answer with this video. So in this first equation, we have cosine of A and we have the cosine and the sine of B. Let's work with the first equation, which would be the cosine of A. We're going to go ahead, graph this out. In this case, we are looking at A being between 0 and pi over 2, which means we are going to be in that first quadrant. If we're looking at the cosine of A, remember, SOHCAHTOA. Cosine is going to be adjacent over hypotenuse. Our hypotenuse is 5, and our adjacent is the square root of 5. We go ahead and solve. This would leave you with square root of 5 squared plus b squared is equal to 5 squared. 5 plus b squared is equal to 25. B squared is equal to 20. B is equal to the square root of 20. Now what we're going to do is go ahead and plug in our values for the cosine of a plus b. Keep in mind, this would give you cosine of a, which would be cosine a times cosine b minus sine a sine b. Find our values. This would be square root of 5 over 5. Cosine of b would be 3 over 5. Minus sine of a, which is square root of 20 over 5. And negative 4 over 5 for sine b. Multiply everything together. 3 square root of 5 over 25 minus. Now, in this case, we have a negative 20, or square root of 20, times a negative 4, which would leave you with a positive 4 square root of 20 over 5. In this case, we're going to combine our like terms. With 3 square root of 5 over 25 plus 8 square root of 5. Now the main reason why we're saying square root of 5 is because keep in mind, this problem, square root of 20 breaks down into square root of 4 times 5, which is equal to 2 square root of 5. That 2 is going to get multiplied by the 4 that's currently there. And we can rewrite this as 8 square root of 5 over 25. 3 square root of 5 over 25. Because they have the same square root, we can actually combine these together. And this would be 11 square root of 5 over 25 as our final answer. Let's go ahead and take a look at B. We go ahead, graph this problem out. Now, since we're looking at a negative pi over 2 up to 0, we are actually going from a negative 90 to 0. So we're going to be in the fourth quadrant. We have sine of b being negative 4 over 5. Keep in mind, if we're working with SOHCAHTOA, opposite over hypotenuse. Our hypotenuse will always be positive. Our opposite, which in this case would be negative 4, would be opposite. Go ahead and find that last remaining section. So negative 4 squared plus b squared is equal to 5 squared. So 16 plus b squared is equal to 25. B squared is equal to 9. B is equal to 3. Because it's in quadrant 3 and we're going towards the right-hand side, that's going to be a positive. We're going to go ahead and set up the equation from the beginning. Notice sine parentheses a minus b. At that point, since it's sine, we would be working with sine of a cosine of b minus sine of b times cosine of a. This will give you square root of 20 over 5, 3 over 5, minus negative 4 over 5, and square root of 5 over 5. We're going to multiply everything across. 3 square root of 20 over 5 minus a negative 4, which would turn this into a positive 4 square root of 5 over 25. Now keep in mind the square root of 20 breaks down into 2 square root of 5. 2 times 3 will leave us with a 6 square root of 5 plus 4 square root of 5. And those are over 25, which would leave us with 10 square root of 5 over 25. This right here can once again be simplified to 2 square root of 5 over 5 as our final answer. Let's take a look at slide 10. Slide 10 is very similar to sine and cosine. Our equation is going to be given. Keep in mind, with tangent, there's one of two equations that you can work with. The top and the bottom are equivalent, but it depends on how everything is written out and how you feel most comfortable. If you are the type of person that likes to see everything written out from left to right and everything clear, you can go ahead and use that top equation. If you have a strong background with your trig functions, you can go ahead and use the bottom equation because it will remain in your head as far as what would work best. Keep in mind, top equation, sine of u plus or minus v. Notice our signs remain the same, which is what we covered for sine. And for cosine, they are opposite. So, as long as you keep that in mind, if you're working with a top equation, you should be perfectly fine. Also keep in mind, that does change within our bottom equation if you're using that secondary equation. Like we said before, it is completely up to you. Let's take a look at slide 11. In slide 11, what we're going to do is we are going to go ahead and work this problem out. It says find the exact value of tan of theta minus beta given. So the first thing that we are going to need to do is graph out our information. So in this case, we start off with theta. Theta is stating that it's between pi and 3 pi over 2, which means that it's going to be in quadrant 3. So pi is over here, 3 pi over 2 would be here. Our triangle would look something like this. If we are dealing with negative 5 over 13, keep in mind, for sine, we are dealing with SOHCAHTOA. Sine of theta would be opposite over hypotenuse. So 13 is always going to be positive because it's the hypotenuse, and we would be dealing with a negative 5 on the opposite side. We're going to go ahead and find that remaining side, which in this case, we would be using the Pythagorean theorem as we've done before. In this case, we would end up with 12. Keep in mind, we are on the left side of our y-axis, which means whatever value you calculate, which would be the 12, would be a negative 12 because we are to the left of our 0. Let's go ahead, do our other equation. We're going to graph that out as well. For beta, notice the domain states that we are between 3 pi over 2 and 2 pi, which means we are between 270 and 0 or 2 pi. Since we are in the fourth quadrant, it would look something like this. Keep in mind, the value is negative 3 over 5. Since it's sine, we're working with opposite over hypotenuse. So hypotenuse would be 5. Negative 3 would be across from that. And we are finding the missing sign. In this case, since we are looking at that missing sign, we are to the right-hand side of our y-axis, it would be a positive 4, not a negative 4. Let's go ahead and work this entire problem out. We'll start off with our simplified equation, which would be the tangent of theta minus tangent beta over 1 plus tangent theta times tangent beta. Start off by finding our values. Tangent of theta would be 5 over 12 minus a negative 3 over 4. Figure out our denominator, which would be 1 plus 5 over 12 times negative 3 over 4. We're going to go ahead, rewrite our equation, and we're going to try to find a common denominator that works with both the 12 and the 4. In this case, you can always multiply by the common denominator, which in this case would be 48. When you do, you're going to end up with you multiplying every single one by 48. I would first simplify this equation and multiply your 5 times negative 3, and that would leave you with a negative 15 over 48. Now that negative you can actually use as your minus sign. Numerator would be 5 twelfths plus 3 over 4. Once again, like we said, we're going to multiply all sides by 48. So here, we're going to simplify. 12 and 48 is 1 and 4. 4 times 5 is 20. 4 and 48 is 1 and 12. 12 and 3 is 36. Over 48 minus 15. From here we simplify. 56 divided by 33 would be our final answer. Highly suggest if you have any questions, please feel free to ask at any point.